So what about 0? 0 of a polynomial means for what value of x that polynomial will be equal to 0. Okay, so if you have a polynomial px is a polynomial. Okay, if pc means if you put x equal to c in the polynomial and you get 0. So if for x equal to c it is equal to 0, then it is called 0 of that polynomial. Okay, so x equal to c is called 0 of the polynomial. Okay, for example, suppose you have given a polynomial x plus 2. It's denoted by px equal to x plus 2. Okay, now you have to check whether minus 2 is a 0 or not. So what do you have to do? You will put minus 2 in place of x. Okay, so p of minus 2 will be equal to x equal to minus 2 you are putting. So minus 2 plus 2 equal to 0. So you have to put x equal to minus 2 on both sides. So p of minus 2 is 0. This means that this minus 2 is a 0 of polynomial. Okay, and another point is 2. If you put 2, so p2 is 2 plus 2, which is 4, which is not equal to 0. Okay, so which is 4 and it is not equal to 0. So this means that it is not a 0. So x equal to 2 is not a 0 of polynomial. What is the difference between roots and zeros of a polynomial? Both are same. Actually, we use the term mainly for the equation, roots of the equations. Okay, otherwise both are same. Okay, we use this root term for the equations. Find a zero of the polynomial. If you have to find the zero in previous example, is making okay, it is in progress now. Is it visible now? Otherwise, I have to make some changes in my sitting. Okay. So let's come to the factor theorem. Okay, it is very, very important. So according to this factor theorem, what does it say? If px is a polynomial, suppose of degree n, which is greater than equal to 1, and a is any real number, then x minus a is a factor of px if and only if, means this I have drawn this arrow both sides, means both sides this result is true. Okay, so pa is 0 if x minus a is a factor of a polynomial. Suppose you have polynomial like x minus 1 x square plus 2. Okay, here you can see x minus 1 is a factor. So according to this theorem, if x minus a is a factor, then pa is 0. So according to this polynomial, x minus 1 is a factor. So you can say that p1 is 0. Because when you will put 1 on both sides, so you have p1 equal to what? 1 minus 1. You will put x equal to 1. So 1 minus 1 is 0. So you have p1 equal to 0. So if x minus a is a factor, then pa is 0. Okay. And if pa is 0, if pa is 0, then x minus a is also a factor of the polynomial. Okay, and this proof is very easy. I have not written here proof, but it is very easy. So it is very important result. Let's do this question. So examine whether x minus 1 is a factor of this or not. So according to this, if x minus a is a factor, then this will satisfy this p a is 0. So if x minus 1 is a factor, then p1 must be equal to 0 for this to be a factor. Okay. So this x minus 1 equal to 0 gives value x equal to 1. Okay. So you have supposed polynomial this. I have denoted the given polynomial by px. So you have given the polynomial px. Okay. And for this px, when you will put x equal to 1, when you will put x equal to 1, so p1 will be come out to be 0. So x minus 1 equal to 0 gives x equal to 1, and you have p1 equal to 0. So this shows that x minus 1 is a factor of px. Okay. So this, in this way we can find the factors. How can we can find the factors? If we are checking for any factor x minus a, we have to substitute a in that polynomial. If it is satisfied or it is come out to 0, then that yes, x minus a is a factor of the given polynomial. Okay. So we have another question also is a factor of this. Now it is given that x minus 1 is a factor. I think it is not okay. Shown your on your screen also example 2. Okay. So in this next example, you have to find the value of k if x minus 1 is a factor of this polynomial. So it is given that it is a factor. So this means that when you will put 1, so this polynomial will come out to be 0 for x equal to 1. So px equal to this, then p1 will be equal to 0 because it is given x minus 1 is a factor. Factor theorem. Okay. So this p equal this x equal to 1
Just a minute. There is,
in this
I think
p.
there is some issue
So
in this
this
tab.
will give the
I
value
think also I should connect by
k.
iPad. रूम से करते हैं. Just
Am I audible now? Okay. So is I'm just explaining this example 2 again. In this example, you have to find the value of k, and it is given that x minus 1 is a factor of this polynomial. Okay. So x minus 1 is a factor. This means p1 equal to 0. In polynomial, if you denote the polynomial by the name px, then you will put x equal to 1 and it will come out to 0. So p1 is 0. Okay. So in px, you will put x equal to 1. So I have this 4 into 1 cube plus 3 into 1 square minus 4 plus k. This is equal to 0, and this will give k equal to minus. Okay. Now move to the next question. Factorize this by using the factor theorem. Okay. So what is this theorem saying? According to this theorem, we have to actually we have to find the factors. Okay. But for factor, and it is actually polynomial of degree 2. So means first thing is there will be two factors. Suppose these factors are y minus a and y minus b, and here the variable is y. That is why I have written it equal to y minus a and y minus b. Now the question is what is a and what is b? Okay, and it is also clear that when you will multiply this y minus a and y minus b, then constant term will be here in the RHS ab when you will multiply, because when you will multiply, so you will get y square minus ay minus by plus ab. Okay, so constant term will be what? Ab. And in our LHS the constant term is 6, so we can say that 6 equal to ab. Okay, now what are the factors of this 6? The factors of 6 are including the negative numbers plus minus 1 plus minus 2 plus minus 3. Okay, now you have to use the factor theorem. You have to use the factor theorem to find the factors. Okay, so actually we are using the this converse part of this theorem. I am showing you the theorem. I think it is length. Okay, okay. So in this reverse part, what do you have? If PA is 0, if PA is 0, then x minus a is a factor. Okay. So what will we do? We will check for every value. We will check for P1, P2, P3. If P1 is 0, then x minus 1 is a factor. If P2 is 0, then x minus 2 is a factor. Okay. So by using factor theorem, we will find the factors. So the points which are to be checked. Okay. So the points which are to be checked, these points will be what? The factors of this 6. So what we are doing? We will factor the constant term. Always we will do the factors of, we will find the factors of constant term. So here in this question, the constant term is 6. Okay. So I have written the factors of this 6. Now I'll check one by one the factors. Okay. So P1, the factors of 6 are, first is 1. So I'll check for 1. So P1 is not equal to 0. P1 will be what? P1 will be 6. When you will put in this Py, so P1 is not equal to P1 is not equal to 0. Okay, so it is not, it will not give you, it will not give factor. P minus 1 is also not equal to 0. When you will put 2, so 2 square minus 10 plus 6, it is equal to, okay. Similarly, you can check for minus 2. So P minus 2 is also not equal to 0. You can check and you can substitute and check. Okay. And you will put P equal to 3, then X equal to Y equal to 3, then in P3. So P3 will come out to be 0 because then you will put 3 here. So you have 3 square minus 5 into 3 plus 6. 3 square minus 5 into 3 plus 6. So it is equal to 0. So this means that P3 is 0. So P3 is 0. This means that another factor is y minus 3. Okay. So by using the factor theorem, okay, you have the factors y minus 2 and y minus 3, which is very important theorem. This theorem is applicable to polynomial of any degree. Yes, you can try. Yes, it is applicable. Even I will tell you about the when I will tell you about the roots of the cubic equation, okay, then I also use this to find one factor, and for other two factors, I'll use synthetic division. Okay, so it is applicable. Another question is x square minus 5x plus 4. So can you try this by using the factor theorem? Can you try this? Ma'am, y minus a, y minus b, how we took? Because there will be two factors, no? So one is suppose y minus a, y minus b. Otherwise, you without taking a and b, you can do directly like this. See here in this question. Here you have x square minus 4x plus 4. So what are the factors of 4? Tell me the factors of 4. Plus minus 1, plus minus 2. Okay. Plus minus 4 also divides, that is matlab, same, and minus 4 is can we can also take, but if we are talking about factors, then plus minus 1 and plus minus 2. Okay, it is divided by 4 and minus 4 also, but for this we can check first, or otherwise you will take also plus minus 4. So is this, suppose I denote this px by this by px x square minus 5x plus 4. So what about p1? 1 minus 5 plus 4. Yes, it is 0. Okay, so x minus 1 is a factor. Okay, then p minus 1. For about minus 1, 1 plus 5 plus 4 not equal to 0. For p2, 4 minus 10 plus 4 not equal to 0. P of minus 2, 4 plus 10 plus 4 not equal to 0. So you can also write here in factors plus minus 4. So what about P4? P4, 4, 4, 16, 5, 4 is 20 plus 4. Yes, 0. So x minus 4 is a factor. So in this way, you have two factors, x minus 1 and x minus 4. Okay. So in this way, you can find the factors by using the factor theorem. I'll also tell you the synthetic division that can also be applied here, but that is more applicable or more makes things easy for higher degrees. But that is also applicable here. I'll tell you later. Okay. So is this fine? Okay. Now factorization by splitting the middle term. So you have ax square plus bx plus c. So I'm dealing with the polynomials of degree 2 right now. Okay. So you have ax square plus bx plus c. If you have to find the factors for this. So there is method of splitting the middle term. So what to do in this? You have to find the factors for such polynomial of degree 2, ax square plus bx plus c. What you have to do? You have to find two numbers p and q such that P into Q is AC, means P into Q is the product of first and last coefficient. First is A and last is C. The P into Q must be equal to the product of these two, and P plus Q must be equal to the middle term B. Okay. So you have to find P, Q's in such a way. So how to factorize? And then what will be the factors? Let's see this example. You have 6x square minus 17x plus 5. Okay. So you have to find P and Q such that P into Q will be equal to 6 into 5, 30, and P plus Q will be equal to 17. Okay. So what you need to do? You have to find the factors of this 30. Okay. So 30 can be written as 15 into 2. 6 into 5 is also 30. 10 into 30 is also 30. Okay. 30 into 1 is also 30. Okay. But what about the second? The condition is that the sum P plus Q must be equal to 17. So 15 plus 2 must be equal to 17 in this question. Okay. So P 15 plus 2 is 17. And for other factors, 6 plus 5 is not 17, 10 plus 3 is not 17, but 15 plus 2 is 17. So this polynomial can be written as like this. Okay. So in this 17 is broken into 15 plus 2. Okay. So you have to keep in mind, and one more thing is also there. I'll tell you in the next example. We are taking here P plus Q because plus sign is there. Plus C is there. Okay. In negative, I will also tell you because we subtract here. So I'll tell you later. So using 30, by taking 30, we have broken this 70 in such a way that the sum is 17 and the product is 30. So we have two terms, 15 and 2. Okay, 17 is written as 15 plus 2. Now multiplying by x. So you have 15x here and another 2x is there. Okay. Now from the first two terms, you can take 3x as common. Okay. So when you take 3x common, so you have 2x because it is 6x square, so 3 is taken outside, so 2 will be there in the bracket, and x square is there, so x outside, x inside. Okay, because you will, when you will multiply again, so you will get 6x square. And in 15x, x is taken common outside and 3 is also there, so 5 is left in the bracket. Okay, so in the bracket you have 2x plus 5. In 2x plus 5, nothing is common, so you can write 1 outside. Okay. Now you can see both brackets are same, 2x plus 5. So you can take this 2x plus 5 as common. So what is left? 3x is left from the first term and 1 is from the second. So you have 3x plus 1 in another bracket. Okay. So these are the factors by using this method. Is this example clear to everyone? If any doubt, any query, please let me know. Okay, great. Let's do this next question. Can you try this? How to do? Which number is to be taken? Which number is to be checked for to be factors? First, here you have 2. Here it is 5. So 2 into 5 is 2 into 5 is 10. Now you have to break this 3. First, find the factors of this 10. What are the factors of this 10? 2 into 5 and what can you write? 10 into 1. Okay, we can write like this. Now you have to find, you need to find this minus 3. How will you get this from these? Yes, 2 minus 5. Someone has written. Now you can see here this before this last term 5, here it is sign of minus. So this will indicate that you have to do subtraction in that those terms P and Q, which are you finding. So you have 2 into 5 is 10 and 5 minus 2 is 3. So this means that you can write 2x square minus 5 minus 2x minus 3 minus 5. Is this okay? 2 into 5 giving 10. You have to break 10 so that the multiplication is 10. So that is 2 into 5. But you have to, now you have to see whether they are to be added or subtracted. So I have done subtraction because minus sign is there before 5 in the question. Okay. The constant term is minus 5. Now the minus sign is there. So this means that those two factors that you are getting, you have to do subtraction between them. Okay. So you have here 5 minus 2. 5 minus 2 is 3. We need 3 because, okay. Now you can open the bracket 2x square minus 5x plus 2x minus 5. Now you can take x common from first two terms. So 2x minus 5 is left in the bracket. And in another one, 1 is taken out common. So 2x minus 5 is again left in the bracket. So what can you do? You can take 2x minus 5 outside. So you have x plus 1. Is it okay? Mohit, you have written x minus 1, 2x minus 5. Check karo. Please check this. And what is the way to check whether our factors are correct or not? Can you tell me? Can anyone tell me? How will check whether the factors are correct or not? Is there any method to check? Put the roots in the equation. Yes. Good. First thing is put the roots means equate x plus 1 equal to 0. So x is minus 1. If you will put x equal to minus 1 in this equation, this will give 0. And from another also x equal to 5 by 2. If you will put the given polynomial, then it will give 0. So these will be zeros. Okay. Any other answer? This is fine. And you can also check by multiplying these two factors. You can yes, Ram. You can multiply these factors. If you get the polynomial back, or same polynomial, this means your answer is correct. Okay. Okay. So let's move to the next question. So factorize this. Try this question by yourself. 12x square minus 7x plus 1. So 12 into 1, 12. So it can be written as what? What are the factors? This will be written as 6 into 2 and 4 into 3, 12 into 1. So which one is to be taken? And keep in mind there is plus sign before 1. Terms will give you 7. Okay. Don't mind this minus sign. Don't consider this. You have to focus on reading. Which factors are to be taken of the 12 so that you get 7?
Don't worry, it will be connected soon. It is disconnected from the tab. Don't worry.
Recording in progress. Recording in progress.
4 and 3. Vicky is saying 4 and 3. Yes. So you have 12x square minus 4 plus 3x plus 1. So 12x square minus 4x minus 3x plus 1. So this gives 4x common. So you have 3x minus 1. I am correct. Just a minute, I am checking. And we take minus 1 common. So you have 3x minus 1 in the another bracket. So now 3x minus 1 is taken as also common. So you have 4x minus 1 left in the next bracket. So you are right, Mohit. Absolutely right. Is it okay, everyone? So these are the factors. So in this way, we can factorize. Good, Mohit. What about others? Are all of you comfortable with this factorization by using the splitting the middle term? Okay, great. Now I have written here some algebraic identities. Okay, so these are very useful, and you all of you must know about these inequalities, these identities. ठीक है. So this is x plus y whole square. Okay, so x minus y whole square, x square minus y square plus y, x minus y. And also I have written some questions, I think. Yes, you will solve these. Okay, so in first one, this a part, you have to factorize using appropriate identities. So 9x square plus 6xy plus y square. So, how to use identity? How to factorize this by using identity? You can see that it is can be written as 3x square plus here it is y square plus 2 into 3x into y. You can write this like this. Okay. So here you can see that a equal to 3x, b equal to y. So it is of the form a square plus 2ab plus b square. It is of this form. A square plus 2ab plus b square. So it is equal to what? This is first identity. X plus y whole square, or we can say a plus b whole square. Okay, so this is equal to what? This is equal to a plus b whole square. A plus b whole square. So what can you write? You can write here 3x plus y whole square. Is this okay? Now can you try the b part? Can you try the b? Can you tell me the answer of this b part? I'll write directly the answer. Can you tell me? If you will tell me, then I'll not solve it. Are you trying? The first term can be written as what? It is whole square of what? Yes, yes, good. Vicky is saying 2y and some others are saying 2y minus 1 whole square. 2y minus 1 whole square. Very good, very good. Correct. So the answer of second is 2y minus 1 whole square. So it is clear to everyone, or should I solve it? Good, Vicky. Great. Okay, so let's come to the third C part. So in C part, you have 8x cube plus 27y cube plus 36 x square y plus 54 xy square. So this first term can be written as like 2x whole cube. Another one is 3y whole cube. Then next is what? This is 3 into 4x square into 3y. If you check it, 4, 4, 16, 9. No, no, it is 2x, 2x inside the bracket. Just a minute. 2x, 2x. So 4, 9 are 36, right? Plus 3 into 2x into 3y whole square. Okay. So 9, 27 into 24, or 54. So is it clear to everyone this step? Yes. So which identity is this? Actual identity is a plus b whole cube. This is equal to what? This is equal to a cube plus b cube plus 3a square b, or you can write 3ab a plus b. 3ab square, or you can also write it like a cube plus b cube plus 3ab. In bracket you have a plus b, both are same. Okay, so when you compare this step with this identity, right hand side of this identity. So what will you find? You will find as a is 2x and b is 3y. Okay. So when you will put a equal to 2x and b equal to 3y, so you have what? 2x plus 3y whole cube. Okay. Yes, Vicky, you are right. Okay. So in this way, you have 2x plus 3y whole cube. And this identity is also written in the above identities. Okay, so I have written there so many identities and taken some questions based on them. So is this okay? Okay, Kiran. What about others? Good. Okay, so in this way you can use the identities. Okay. Another is okay. One question is also left. D part. D part is left. So it is what? It is x square minus y square upon 100. So it can be written as a square minus y upon 10 whole square. Okay. Now there is another identity. What is that identity? Identity is a square minus b square equal to a minus b and a plus b. A square minus b square is a minus b, a plus b. Okay. So you can apply in this question, in this D part. So you have a, you have to put a equal to x and b equal to y upon 10. So this will give you x minus y upon 10 and x plus y upon 10. Okay. So x minus y upon 10, x plus y upon 10, these are the factors for this given identity, given question. Okay. So identities are used to find the factorizations. Okay. These helps to factorize. And many other applications are also there of these identities. So these are some basic identities that I have applied on these questions. Okay. So, so I hope this part is clear to everyone, because now I have to move for the solutions of or for the roots of quadratic and cubic equations. So is there any query? Everything is clear? Okay, good. So what is quadratic equation? You know quadratic polynomial, I just told you. Quadratic polynomial means polynomial having degree 2. Okay. So polynomial of the type ax square plus bx plus c is quadratic polynomial. Here a is not equal to 0. Or you can say the highest degree of x is 2. Okay. So a must not be 0. Okay. B and c can be 0, because if b and c are 0, so you are left with ax square. This is again a quadratic polynomial. But suppose if a is 0, and then you are left with bx plus c. B and c are non-zero. So this is not a quadratic polynomial. Okay. So keep in mind this coefficient of x square must be non-zero. Okay. So this is quadratic polynomial. Now what is quadratic equation? So when this polynomial is equated to 0, you get quadratic equation. Okay. So polynomials are special forms of expressions, and equations are obtained when the polynomial is equated to 0. Okay. So if quadratic polynomial is equated to 0, so you have quadratic equation. Now the question is, what are roots of quadratic equation? I have also written some examples here for the quadratic equation. These in the left hand side all are quadratic polynomials. Okay. And these are equated to 0. So these are quadratic equations. If we talk about roots, the roots means the value of x that will satisfy the equation. Okay. So the value of x that satisfy the equation of with which equation? Equation 1. Then I have noted this quadratic equation by equation 1. Okay. So the value of x that satisfy this quadratic equation is called roots. Okay. Now how many roots will be there? 2 roots. Why? Because the degree is 2. Okay. So for quadratic polynomial, maximum number of roots will be 2. For cubic, It will be 3. So one method is by using the Sridharacharya formula. So Sridharacharya formula says, yes, Vicky. It says x equal to this minus b. If the equation is this ax square plus bx plus c equal to 0, so the roots, the value of x is minus b plus minus under root b square minus 4ac upon 2a. Okay, so this is the formula for finding the roots. Okay, and this part, this b square minus 4ac is called as discriminant. Okay, so if we, this is denoted by d. If you are finding roots for an equation, it is not necessary to use the symbol d. You can directly put in this also. Okay, but I have written this here because I was writing some results. So if I use the notation d for this b square minus 4ac, which is discriminant, so the x is equal to minus b plus minus under root d upon 2a. Okay, so this is formula. Now, when d is positive, when d is positive, d means the b square minus 4ac is positive. Okay, the term inside the square root is positive. Then what do you have? You have two distinct roots. You have two distinct. Why two? Because the sign plus minus one is there. For one plus sign, one root. For minus sign, another root. Okay. So suppose these roots are denoted by alpha and beta. So when d is positive, you have two distinct roots. So keep in mind this result. Okay. But when d is 0, when d is 0, so what do you have? When you will put here d equal to 0. So when you have this d equal to 0. So you, what do you have? This you have minus b plus 0 upon 2a and minus b minus 0 upon 2a. Okay. So when you add 0 or subtract 0 in minus b, you will get minus b. So both of them will give you what? Both of them will give you minus b upon 2a. So this means that you have equal roots. So I have written here, when d is 0, then ax square plus bx plus c equal to 0 has two equal roots. Okay. And what are these roots? These roots are minus b upon 2. Okay. Next is when d is negative. So when you have negative term inside the square root, so this will give you complex roots. Okay. Complex numbers we will study later. Okay. So this will give you complex roots. Okay, then I have taken some examples. So the first one is find the roots of this 2x square minus 5x plus 3 equal to 0. And there are so many methods. This is one of the methods. Okay, by using the splitting the middle term, we can also do this. So for this, you can write this Sridharacharya formula. Okay, in this question, you can see that A is 2, B is minus 5, and C is what? 3. Okay. So in this formula, you have to substitute the values of A, B, and C. When you will substitute these values, you have this step. Okay. And for this, when you will simplify the terms in the square root, you have what? 24 minus 4 into 2 is 8. 8 into 3 is 24. 25 minus 24 is 1. Square root of 1 is 1. So you have this 5 plus minus 1 upon 4. Okay, so you will take plus and minus one by one. So when you take here plus sign, so you get 5 plus 1 6, so you have 6 by 4. But when you take subtraction sign, so you have 5 minus 1, which is 4, so so it is 4 by 4. So 6 by 4 gives you 3 by 2, and 4 by 4 gives 1. So the values of x are 3 by 2 and 1, and these are the roots of the given equation, given quadratic equation. So is it okay to all of you? Okay, great. Let's do for the next. Can you tell me the roots of this equation? Minus one, Vicky. No. 1 and minus 1, Mohit? No. Hmm. See, you have here A equal to 1, B equal to minus 2, C equal to 1. Okay. So what do you have? You have x equal to minus of minus 2 plus minus square root minus 2 whole square minus 4 into 1 into 1. Okay. So you have what? 2 into 1 in the denominator. So this is 4 plus minus in the square root you have, sorry, why 4 like 2 plus minus under 0 upon 2. So you have 2 plus 0 upon 2 and 2 minus 0 upon 2, which is 1, 1. Yes, Mohit, Vicky, is this okay? Is it okay to everyone? Okay. Can you do this next one? Here you have x a equal to 3, b equal to minus 1, and c equal to 4. Okay. And you have to apply the formula. So what is formula? Minus b plus minus under root b square minus 4ac upon 2a. So minus b means minus of minus 1 under root minus 1 whole square minus 4 into 3 into 4 upon 2 into 3. D is less than 0. Okay. 4 3s are 12. Okay. Suppose I change this question and I put here minus. Can you do it now? You are right, Kiran. Now I am changing this question. Do it now. If it is positive, then we will write okay, no real roots. Okay, because we are not dealing with the complex numbers right now. Okay, and suppose if it is minus sign, then what will be the root? If c is minus 4, then what are the roots? 8 by 6, good. And it will be minus 1. Mohit? Huh. 4 by 3 or minus 1, that's fine. Sohan? Yes. After taking here plus sign, so it will be 8 by 6, means 4 by 3. And when you take minus sign, so this will be minus 6 by 6, means minus 1. So minus 1 and 4 by 3. These are two roots. Good. X square plus 1 equal to 0. Again, D will be negative. So roots will be imaginary. No real root. Plus minus I, yes. Because under root minus 1 is iota. So this will give you actually what? Plus minus square root of minus 1, and minus 1 it is iota. So these roots are imaginary. Yes. Okay. So we will deal with complex numbers later. Don't worry. Iota means under root minus 1, Mohit. Okay. So let's move to the sum and product of roots without finding the equation, because if you have equations, okay, and I asked about the sum and product of roots. The one thing is we first find the roots and then take sum and product. This is one way to find the root sum and product of the roots. But there is another way also without finding alpha beta, without finding the roots. If you have only equation, so by using the equation, you can easily find sum and product without having its roots. So what is the way? What is that way? Without finding the roots, we can find the sum and product. So the way is that you can find the sum like alpha plus beta. Alpha and beta are roots. Then alpha plus beta is what it is? Minus b upon a. By only simply looking at the equation, you can write the roots, the roots of sum of the roots. So this is equal to minus b upon a. And the product of roots is c upon a. For example, in this question, you have given this quadratic equation, okay, and you have to find the sum and product of roots. So what will be the sum of roots? If alpha, beta are denoting the roots of this equation, then what will be the sum? Formula is minus b upon a. So what is b and what is a here? B is 3. B is what? Coefficient of x. A is what? Coefficient of x square. So a is minus 2. So you have 3 by. So this is sum of the roots. So without finding the roots, you have sum of the roots. Okay. Similarly, you can find the product of the roots. So what will be the product of the roots? It is equal to c upon a. So c is what? This is minus 5. So minus 5 upon a is minus 2. Minus minus cancel. 5 by. Okay. Is it okay to everyone? Okay. Now, formation of an equation with given roots. Now, if you have given roots, then how can you build the equation? Okay. So, if we are talking about this quadratic equation and you have the roots alpha and beta, so the equation is this: x square minus sum of roots means alpha plus beta into x plus the product of roots alpha beta. Okay. Or you can also write x minus alpha, x minus beta equal to 0. Okay. So this is also one way. Then you will, when you will multiply these two factors, you will get the same equation. Okay. So let's see example. If 2 and 3 are the roots of a quadratic equation, find equation. So you have roots means you have alpha and beta. Alpha is 2 and beta is 3. So to write the equation, you have the formula x square minus alpha plus beta into x minus plus alpha beta, which is written there. Okay. And it is an equation. So right side it will be equal to 0. So now you know alpha and beta. You can now substitute the value of alpha and beta in this. So you have equation that has the roots 2 and 3. Is it okay? So what will be the answer? X square minus 5x plus 2 3 is 6 equal to 0. Is it okay? Great. Good. Next is, if alpha and beta are the roots of the equation 3x square minus x plus 4 equal to 0, then find the quadratic equation whose roots are 1 upon alpha plus and 1 upon beta. So you have given one equation, this. You have its root alpha and beta. Now you have to find an equation having roots 1 by alpha and 1 by beta. So from this equation and these roots, what information do you have that we have learned just now? It is that you can write sum and product of alpha and beta. You can write from this equation. Okay, so sum is what? Minus b upon a. So in this equation, a is 3, b is minus 1, b is equal to, I'm writing again, b equal to minus 1 and c equal to 4. So A is 3, B is -1, C is 4. So you can use the values. Alpha plus beta is what? This is minus B upon A. Minus B upon A. So minus as it is. B means -1, A means 3. So this is 1 upon A. Then alpha into beta, C upon A, which is 4 by 3. Okay. But you have to find the equation having roots 1 upon alpha and 1 upon beta. And you know how to find the equation having roots. Having or given two roots. So for this, for equation having these as roots, what do you need to find? You need to find sum and product of these two roots. Okay. So what will be the sum? 1 upon alpha plus 1 upon beta will be equal to what? You will write it as alpha plus beta, beta plus alpha upon alpha beta. Okay. And you have the values of both of the terms, numerator and the denominator. So this will be equal to 1 by 4. Okay. And the product will be 1 upon alpha beta means 3 by 4. Why? Because alpha beta is 4 by 3 and this is 1 upon alpha beta. So this will be 3 by 4. Okay. Now you have sum and product of 1 upon alpha and 1 upon beta. Now how to write equation? You know that the formula is x square minus sum of the roots. In the formula I told you earlier, sum of the roots, whatever the roots are, you have to write sum of the roots into x, then product of the roots. Okay. So here it is written like x square minus sum of the root is what? It is 1 by 4 into x plus product of the roots. Okay. And it is equated to 0. So is this clear to everyone? How to find the roots? How to find the equation from roots? Or how to find sum and product of roots from the given equation? Okay, Kiran, Mohit. What about others? Are you all getting? Gaurav, Arnav, are you all getting? Great. So let's move to the cubic equation. Okay. So cubic equation means it is obvious that the degree will be 0 or highest power of x will be 0. So this is the general form of the cubic equation, ax cube plus bx square plus cx plus d equal to 0, where it is compulsory that a must not be equal to 0. Otherwise, it will not be a cubic equation. Okay. Now, what about roots? If alpha, beta, gamma, these are three roots of this equation 1. Then what do you have relation between them? In quadratic equation, you have alpha plus beta. Here you have alpha plus beta plus gamma, sum of all three roots. And it is what? It is equal to minus b upon a. Okay. Like in quadratic equation you have. Okay. So sum of the roots is minus b upon a. Then in quadratic you have product of two roots alpha beta is c by a. But if you take product of two roots alpha beta, so this is alpha beta, but there is another root gamma also. So this is beta gamma, another one is gamma alpha. So if you take product of any two roots and you add all them, you take two and then add. So alpha beta plus beta gamma plus gamma alpha. So this whole term is equal to c by a. Okay. Then the product, all these three roots, alpha, beta, gamma, this is minus d by a. So keep in mind, in this equation, you have here b, c, d. Okay. So minus b by a, then for this c, this plus sign, plus c by a, then for d, this minus d by a. Okay. So minus, plus, plus. Okay. So for this equation, you have given example. For this, you can find alpha plus beta plus gamma and another two also, alpha beta gamma, and this sum alpha beta plus beta gamma plus gamma alpha from this equation. Okay. So it is very easy. You have ABC you have A equal to 1, B equal to -5, C equal to -2, and D equal to 24. So substituting all of these in the formulas, you have values of this. Okay? Is that okay to everyone? Okay, great. As you know how to find equation from the roots in case of quadratic equation. Okay, for in case of quadratic equation, when roots are given or the sum and product are given, then you can find the equation. Similarly, you can find in case of cubic. Okay, cubic equation. So if you have three roots alpha, beta, gamma of a cubic equation, then you can also form the equation. The formula is x cube minus sum of the roots alpha plus beta plus gamma x square plus sum of the products taken two at a time alpha beta plus gamma alpha into x, then minus alpha beta equal to 0. Okay. So by using this, you can form the equation if you know these terms or you know alpha, beta, gamma. Okay, so this formula you can use in the given example. You have given the roots, means you have alpha 1, beta 2, and gamma equal to 3. You have to find cubic equation. So cubic equation has three roots. Okay. Now, how will you find? You need to find first alpha plus beta plus gamma. So what it will be? Can you tell me the answer of this question? What will be the cubic equation formed by using these three roots? You have to find these terms, alpha plus gamma, alpha beta, beta gamma, gamma alpha. First tell me these terms, values of these terms. Then you can directly tell me the equation. What are the values of all these three? Who will tell? Six, 11, 3. 6 is the sum of roots. Okay. Now you are saying 3 is the product. How? Alpha into beta into gamma. Yes, 6. And middle one is 11. Alpha into beta is 2. Beta into gamma is 6. Gamma into alpha is 3. Okay, right. 11, fine. Then what will be the equation? Now it can be written as x cube minus sum of the roots. 6, then x square, then plus, then this sum of the product taken two at a time. So 11x only. And then minus 6 equal to 0. It is to be noted that the sign is alternative. First term is positive, second is negative, then positive, then negative. Okay, the sign is alternative. It's changing. Plus minus plus minus. Is it okay? Great. Now, very interesting. I think it is now. Yes, I'll tell you about the synthetic division method, which I like very much. I like so much this method because when do you like this method, you will never use that long division method or any other method. So if you have this cubic equation, x cube minus 5x square minus 2x plus 4. First thing is you know that this is cubic equation and cubic equation will have three roots, okay? And at most one root will be real. So that real root we can find by using the factor method or you can say by using the hit and trial method. So what you can do? You can write the factors of this 24. Okay. So I have written the factors of this 24 plus minus 24 all can also be written. I have not written here. Okay. So you can write the factors of this 24 including negative and positive all. So, and then you can check one by one or by trying some of them, which one is satisfying this equation. Okay. So, what will happen? Let's see. First, we find that which of one of them is satisfying the given equation. So, one is not satisfying because when you put x equal to 1, it is not equal to 0. X equal to minus 1 is not equal to 0, not giving 0. X equal to 2 is also not giving 0. Minus 2 is also, minus 2 is giving 0. So, this means that x minus 2 is a root. Or if you need to find factor, then you can say x plus 2 is a factor by factor theorem. Okay. So whether according to the requirement, you need to find factor or root, whatever you can write. Okay. So minus 2 is a root. Is that fine? How many roots are left to find? In cubic equation, you have one root by using this factor theorem, or you can say hit and trial method. You can put number, but that number, keep in mind, must be a factor of this last term, constant term, which is 24 in this example. Okay, yes, yes, you are right, Mohit, Vicky. We need to find two more factors or two more roots. Okay, because in this question I have written what solve. It is to be solved means you have to find roots. Okay, now there are two things. One thing is that which I don't do, but I'm telling you. One thing is that we divide the given cubic expression by x plus 2. Long division that you do in your, I think, 6th or 7th standard. Okay, that division. But why? Why we are doing like this? You have actually cubic equation, right? And you know that that cubic equation has one linear factor which is x plus 2. So another factor will be quadratic. This factor will be quadratic of degree 2. You know that if you have cubic equation and if we take the polynomial part of this and you have one factor of that, this means that another factor will be quadratic, and using that quadratic factor you can find the roots of that quadratic equation by equating to 0. You know that. Now the question is how to find that quadratic factor. How to find that quadratic factor, quadratic polynomial that will give you another two roots. Are you getting my point? Are you getting my point? What do I want to say? Okay. So if you have some cubic part here or cubic polynomial type here, so I'm saying that yes, linear, you have one linear factor, okay, linear factor into quadratic factor, okay. So it will be like that, okay. So we need to find that quadratic factor. So for that, I am going to teach you one method that is known as synthetic division method. Very easy, very important, and very easy to use actually. So what to do? So I just write this equation again here because I have to go in the next page. This is given, okay? And you have x equal to minus 2 is a root. Okay, so if one root is known, so in synthetic division, what to do? You have to draw a line like this. Then you have to write factors of the given cubic equation. So coefficients are 1. The coefficient of x cube is 1. The coefficient of x square is minus 5. Coefficient of x is minus 2. Then constant term is 24. And outside you will write minus 2. From where it comes? This is minus 2 because x equal to minus 2 is root. So we will put this minus 2 outside. Okay. So in this way, first you will write. Then what will you do? You will write this one as it is. This first term, whatever this is, you can write this first term as it is. Now multiply this minus 2 in 1. So minus 2 into 1 is minus 2. So put here. Okay. Now add these two. What will you get? -7. Okay. Now multiply this 7, this -2 into -7. What do you have? +14. So it will be sent here. Okay. Now again add these two. You have 12. Okay. Now multiply this -2 into 12. So you have -24. This is you. If you are doing correctly and you have this -2, this root -2 correct, then definitely you will get here 0. Okay. So you have 0. Now these three terms will give you quadratic factor. And what is that factor? That factor is x square minus 7x plus 12. Now you can find its factor very easily by using the splitting the middle term, by using Vishikaracharya, by using factor theorem, and so what can be the factors of this? This is 12, 3 4s are 12, and this is 7, so 7 is 3 plus 4. So you can write as 3x minus 4x plus 12. So you can take x common, so it is x minus 3, then minus 4 common, x minus 3, then you have x minus 3, x minus 4 equal to 0. Equal to 0 because we are solving the equation that, okay, here it is equal to 0 right hand side. So you have what? X equal to 3 and x equal to 4. So in this way, you have three roots, -2, 3, and 4. Is it okay? Are you getting the synthetic division method? The next question will be done by you. Are you ready to find the roots of the cubic equation by using the same method? Are you ready? I'm going to give you one question. What happened? Vicky, Mohit, Gaurav, Arnab, and others are also there. Soham, Kiran. Is it okay? Yes. So keep in mind, I'm just repeating in short, then I'll give you one question. First, keep in mind, you have to first find one root, okay? By putting in the given equation, and by you have to first write the factors of the constant term, then you will check one by one and you will get a factor. Okay, that means the value that will give you value 0. Okay, so by putting you will get the value of equation 0 means you will get one root. So if you have one root, okay, and then what will you do? You will write the coefficients in this way. Okay, you will put the root outside. Okay, then you will use this method. So what is this method? First, write the first term as it is. It is 1 here, so I have written 1. Then multiplied this -2. So -2 into 1 is -2. So -2 is here. Then I'm using another color. Okay, so it will be much better. Okay, so this is -2. So -5, -2 are added. So you have -7. Then again, this -2 is multiplied with -7. So you have 14. Then 14 is added in this -2. Okay, so you have this 12. Then -2 is again multiplied in 12. So it gives -24. So I have written here -24. These are added, so 0. So if this root -2 is correct, then definitely it will be 0. Okay, it is not 0. This means there is mistake. Okay, so now these three terms will gives you this factor, quadratic factor, and you can factorize it very easily. So let's move to the next question. So find its roots. So can you find its one root by using the factor theorem or by using any value of from the factors? What are the factors of this 6? Write the factors of 6. Can you tell me? Factors of 6, yes, Kiran, but not only positive. 1, 2, 3, 6, you are right, but plus minus both. Okay, you are right. So plus minus 1, plus minus 2, plus minus 3, plus minus 6. Okay, so now you can check. So 1 will not satisfy. Okay, and what about minus 1? When you will put minus 1, it will give you 0. Okay, Jolly, you have found. Okay, great. I'll check. Okay, so minus 1 is correct. So minus 1 is the root. X equal to minus 1 is the root. Is it okay to everyone? Now, what to do? So now when you will apply the synthetic division method, so what coefficients you will write? Type the coefficients in the chat box. What are the coefficients you will write? 1 minus 7 minus 6? No. That is why I have taken this question. Keep in mind, you have to write the coefficients of each and every term. Yes. Jolly is saying yes. Now it is correct, Jolly. So no, you have missed 0 because they see x cube is there, so coefficient is 1. X square is absent. So for absent, we will write 0. Okay. Then because always compare with the standard form. So coefficient of x square is 0, then coefficient of x is minus 7, then constant term is minus 6. And you have one root which is minus 1, so I have written it outside. Okay. Vicky, I just check. Don't worry, Abhi. Now I'll check. So first root is 1. So 1 as it is, first term is 1, 1 as it is. Now you will multiply this minus 1 and 1. So you have minus 1, write it here. Now 0 and minus 1 are added, so you have minus 1. Okay. Now again minus 1 and minus 1 are multiplied. So this will give 1. So now these two are added, minus 7 and 1. So it is equal to minus 6. Okay. Now minus 1 and minus 6 are multiplied. So give 6. So it is written here. And minus 6 and 6 are added, gives. Okay. So this means the minus 1 root is correct. First thing is this. Second thing is we have quadratic factor x square minus x minus 6. Okay. And it is equated to 0. You can now find x. Okay. So what will be the roots? So 6 is what? 2 into 3. And here subtraction sign is there. So 3 minus 2 is 1. We need 1 because coefficient of x is 1. Minus 1 actually, but if we don't take minus, so it is 1. So this is what? This is 3 minus 2x minus 6 equal to 0. So this is x square minus 3x plus 2x minus 6 equal to 0. So taking x common, so taking x common, x minus 3 plus 2x minus 3 equal to 0. So you have what? You have x minus 3 and x plus 2 equal to 0. This gives x equal to 3 and minus 2. 3 and minus 2. Yes, Vicky, you are right. So many of you have written the answer. So the roots are minus 1, minus 2 and 3.